Okay, so electrolysis is a chemical change caused by passing an electric current through a compound, which is either molten, most important, or in solution. An electrolyte is a liquid or solution that undergoes electrolysis. Electrolytes all contain ions, and it's the movement of the ions responsible for both the conduction of electricity and the chemical changes. So, as you remember, we talked recently about ions, and you have your positive ions that are mostly metals, except for hydrogen and ammonium. The negative ions can be monoatomic, like the halides, and polyatomic, in which case they react as a group with a specific charge. They do not decompose or do anything at all. Actually, in electrolysis, this type of ions do not react at all, but they are a group with their negative charge. So, the electrolytic cell consists of a container where the electrodes are immersed. Usually the electrodes are inert. The electrolyte contains ions, positive and negative. The positive move towards the cathode and they take electrons from it. They gain electrons, so there is a reduction. And ions move towards the anode, where they release their electrons, and so the circuit is complete with the ions that transport the electrons, and they go through the whole circuit. So we just said that this electrolysis can happen in only if the salts are molten or in solution. When the salts are molten, you have ions that only come from whatever the salt is made of. Like in this case, sodium chloride is made of sodium ions, chloride ions, and the circuit will be closed and electricity will circulate and this little lamp will light up only when the salt is molten. If this is cold, there is no light. The light is just to see that there is a circuit that is complete. While if the salt is in solution, there are ions that come from the salt plus the ions that come from water. So when the electrolysis happens, it's all these ions that participate. Now, just as a quick reminder, because that is always part of some of the questions, ionic compounds can only conduct electricity in the molten state or in solution, because otherwise the ions are in fixed positions and they are unable to move. So, we are first going to talk about molten salts, the electrolysis of molten salts, which are the most immediate one. And the examples, for instance, are lead bromide, sodium chloride again. Now, they often ask in one of the questions how you would set up the experiments to do that. That is as a part of a question. So put it in a crucible, heat up so it will melt, allowing ions to be free to move. Add the graphite rods as the electrodes, connect to a power pack, turn on the power pack, and the electrolysis takes place. It's a very simple type of setting. Now, when this is molten, you will have positive charge lead ions that will go to the negative electrode, take 2 electrons, and sediment as lead metal. Then the bromide, negatively charged, goes to the positive anode, releases the electrons, and becomes bromine gas. Similarly for the sodium chloride, molten. The electrodes are kind of put the other way around, but it doesn't really matter which way they go. The negative chloride will go to the positive electrode, will discharge its electrons, turn into chloride gas, while the sodium positive will go to the cathode, take electrons, and form sodium solid, which is actually seen as how reactive sodium is, the only way to prepare it, because there is nothing else for it to react with, and so it will be deposited as sodium metal. Other examples that can come up, which are equally simple, copper chloride, and in this case, copper chloride, the copper have positive charge attracted to the cathode and form copper metal. Take the electrons from the cathode and becomes metal. The chloride ions have a negative charge. They go to the anode, they release their electrons and form chlorine gas. Same with molten magnesium oxide. Magnesium positive takes electrons, turns into magnesium metal, and the oxide releases electron and becomes oxygen gas. The oxides only can be electrolyzed as molten, not in solution, because magnesium oxide in solution will have a reaction totally change. So, before we go into the electrolysis of aqueous solutions, just a little reminder of now, in an aqueous solution, you are going to have, as we mentioned earlier, several ions to choose from to see which reacts and why. So just a reminder of the electronic structure of sodium. Sodium, that is a metal, that's a metallic structure. It has 1 electron in the outermost shell. And when it reacts and becomes an ion, it acquires a kind of more stable electronic structure with 8 electrons in the outer shell. And having achieved this structure, is not really very keen to give it up, and is not likely to react with anything that will bring back an electron here. While hydrogen, which is a gas, diatomic gas in reality, has 1 electron in its outer shell. When it becomes an ion, loses that electron and becomes positive ion hydrogen. So this one is actually quite happy to get an electron back to get, a more stable electronic structure. So when salts are in solution, salts can be made up of any of these ions. The salt can be a salt of potassium, sodium, lithium, aluminium, copper. So when it's in solution, you have all these ions with these respective charges. Now, these are the most reactive metals, so that they will most happily go into an ionic form. And the most reactive are the ones that form ions that are more stable and more difficult to discharge, while the ions that are least reactive form ions that are least stable and easiest to discharge. And in our case of solutions are water solutions, what matters to us is the discharge of hydrogen compared with the discharge of anything else. So the most reactive ones will not discharge. Hydrogen will be, if it's preferentially discharged rather than any of the reactive ones. But the least reactive ones will be discharged preferentially with respect to hydrogen. If it is a salt that contains copper or silver, it will discharge easier than hydrogen. So that is the positive ones, that are the ones that one really needs to keep in mind and remember the reactivity scale, because otherwise you will know which one is going to discharge. As far as the negative ions is concerned, it's a lot easier because the only ones that discharge are these four. The halides and hydroxide, none of the other ones will. So if there is a salt that has any positive ion and any of these as a negative ion, these ones will discharge preferentially to the hydroxyl one. So in water, if there are halogens, alhalides, sodium chloride, potassium bromide, sodium iodide, this one will discharge first. But you see, if instead of halides there is, this is always from water, but if there is sodium sulfate, copper nitrate, those do not discharge, and it's hydroxide that will. So I'll show you some example, just a couple. So this is the electrolysis of sodium chloride in solution this time. So you have hydrogen and hydroxide from water, positive hydrogen, sodium and chloride from the salt. So you got the four ions. So because there is a halide, though you have hydroxide from water, the chloride is the one that is going to discharge, forming chloride gas. So two chlorides form chlorine and releases two electrodes. And from between sodium and hydrogen, because this is most reactive, hydrogen is the one that's going to take the electrons and form hydrogen gas. Now, as you see, both the products are gases, so usually the configuration of the electrolytic cell is like this, in some way to catch the gas that is formed, either for testing or for collecting or for whatever. And it's exactly the same, it's just the power supply, the electrodes, except that the liquid is contained in some enclosed contraption. And the one that is also often in the questions, in the exam, is the electrolysis of copper sulfate. And in this case, you have from the salt, sulfate and copper, from water, hydroxyl and proton. Now, from the negative ions that go towards the positive electrode, sulfate does not react. The hydroxyl one will react and form oxygen and water, and that bubbles out as oxygen. But the one that's in here, one must remember the reactivity scale. Copper is least reactive than hydrogen, so copper will be discharged rather than hydrogen. So you have at your cathode, copper takes the electrons, forms copper metal, and deposits around the electrode. So that is, one of the few examples where your cation will metallic one will discharge rather than the hydrogen. And so that's why it's not too many. It's almost always in your examples it's going to be copper, it could be silver, but mostly just those that you have to remember. All the other ones, it will be hydrogen that discharges. And so the questions that can come in an exam are things like this. The half equations, of course, show the transfer of electrons. That's the movement of electrons. They're called half equations, and they ask always to be balanced. So in the electrolysis of lead bromide, you have your lead that takes electrons and turn into lead. Lead ion turns into solid lead. Bromide goes into bromine gas, and releases electrons. So in the molten potassium iodide, you only have potassium as an iodine again. So the substance that will form at the negative electrode, at the negative is the potassium that is discharged as potassium, and the other one in the positive electrode is going to be iodine. If you remember that in potassium iodide, you have this is positive and that is negative. So, and then they do almost always ask if there are examples of oxidation or reduction, either of them or both. So for iodine, because the iodide loses electrons, is an oxidation. You remember, oxidation is loss. And this one is one of the more complete ones that they might ask. Electrolysis of a variety of aqueous solutions says here. They ask to draw the diagram of the electrolytic cell with labels. They want the cathode, the names of the electrodes, the fact that the electrodes are immersed in the electrolyte label, and again, anode and inert electrode, whatever, they cathode and anode, and this is the power supply. So if you're talking about copper sulfate, it says show the ions that are in the solution, and it's these four. Copper is produced, write the half equation, so copper plus takes electrons and goes to copper metal. And it says when potassium nitrate solution is electrolyzed, neither potassium nor nitrogen are produced. Explain why. So nitrogen is not produced because nitrogen is not affected. Potassium is more reactive than hydrogen, so hydrogen is produced. And because there are no halides, from the hydroxide of water, oxygen is produced, and you don't produce nitrogen because the nitrate group does not electrolyze. And then they also can ask just to write the equation, the half equations of the electrolysis. Again, lead bromide, zinc chloride, sodium iodide, and it's all the same. The positives take the electrons, the negatives release the electrons. They have to be balanced. And this one's in solution. Now you have the four ions, and you have to decide which ones are going to react. So iodide in preference to hydroxide, hydrogen in preference to sodium. So it's hydrogen that forms hydrogen ion that forms hydrogen gas, iodide that forms iodine. I can't remember if it is gas or solid at room temperature, either of them. Calcium chloride, copper chloride, you have copper, you have chlorine, hydroxyl, and hydrogen. And now your copper is less reactive than hydrogen, so that is the one that discharges, and the chloride is preferable to hydroxide, so it forms chloride. And with dilute hydrochloric acid, you only have chloride, hydroxide, and protons, 2 hydrogen ions plus the electron from hydrogen gas, 2 chloride forms chlorine plus 2 electrons. This time, as you know, that one is preferential. Now, the other question that is very similar, just one slightly different wording, is again what's called lead bromide. So they ask why solid lead bromide does not conduct electricity. As we said, electrons are not free to move. Why this reaction is described as oxidation? Because electrons are lost from the bromide. Then they want the electronic half reaction, and then they want to know what is the appearance of the product. So if lead ions go into solid lead, you just have to remember that solid lead is gray and shiny, perhaps, not always. And the other type that they ask is they give you all the bits to build up an apparatus, and it asks you to actually set it up to measure the electrolysis of potassium chloride. So you got your power supply, your electrodes that need to be secured in this end, the tubes that are inverted on top of the electrodes. This is your container where the electrolysis takes place, and what they actually, they give you the wires, what they actually most want is that the solution of electrolytes covers the electrodes and is inside the tubes. They don't care exactly which level, as long as the electrolyte is covering the electrodes and the bottom of the tubes. So I don't know if this has been any good. I hope so.